I guess just to start, so code generation tools in general, there's a lot out there. So I am going to, distinguish a little bit, and we'll get a little more granular as we go further into this. And we're going to look at really, again, from generalities, some pros, some cons. I'm going to have a list of several that will probably be useful because they're out there more often, I think, than we realize sometimes. And some of these are things we will have heard of before that I know we've talked about even in this class. But when we want to quickly get something done, they don't always jump to mind. And particularly, probably that goes into some of the pros and the cons that we're going to talk about. So moving forward to this presentation, I'm going to do a quick little introduction about it, talk about code generators, and put some definition in. And this is not necessarily, this is going to be our definition for the purposes of this presentation. This is not necessarily some Webster's dictionary definition or anything like that, because it really is a very broad topic and broad label. So we're going to narrow this down a little bit so that we can specifically look a little better at some of these, particularly as it regards to their strengths and the pros, or the weaknesses and the cons to these varying approaches. And then really frameworks although some of them do code generation, like if you think of Hibernate is a great example I think most of us have been exposed to, where you point at a database, you configure some stuff, and it will generate code for you. But I tend to think of those kinds of frameworks typically more of like a middle ground. They're not really a full-blown code generator. They're going to generate, they generate essentially a framework. They generate something that you're going to build off of. And the distinction really there is that these frameworks like Hibernate itself is not going to generate you an application like just off the ground, just you hit a button, do a little bit of configuration, hit a button, and boom, you've got an application. You've got something that you're going to have to build on top of to make it useful at all. So I'm going to look at those a little bit, frameworks and some libraries. And as I promised, I'll finish up with some options, some stuff that's out there, some that you've heard of, and probably some that you've heard of, and probably some that you haven't, just to give you a list of some things to look for, and even some things to consider that maybe you haven't when you run into these kinds of situations. So first, let's just sort of getting started on code generators in general. So for this purpose, what is a code generation? A code generator? Well, it's going to provide fully functioning code blocks at least. If you think of building something with Legos, code generators at least are putting together some pretty decent sized Legos. They're not necessarily an app generation. So this is different from no or low code. No or low code kinds of solutions typically will provide you they're an application generator. They will put together an application where you click a few buttons and boom, you're off and running. Code generators are really one step beneath that. So they're going to create some blocks, and then you can connect the blocks, and then you've got an application. But it's not complete, but it is close enough so that you really don't have to put a lot of code into it. It's really configuration and linking and a couple of things like that, and maybe a bit of scripting or something like that typically from a code generator. There are lots and lots out there. Code generation has been around probably since 2 days after somebody wrote the first couple lines of code. I mean, just programmers generally, that's our strength, and our weakness is that we're lazy. So we get tired of writing the same code over and over again. And all of us at some point probably have built a utility to at least, copy and paste stuff, generate code some way, somehow just remove the tedious parts and make that automated. And so with code generators, some of them they have their own language. And if you think, and a lot of them are actually probably derivatives. So if you think of, for example, like some of the well-known, low code and out of the box types of solutions like NetSuite or Salesforce or PeopleSoft or stuff like that, they have a specialty language, even though typically if you look underneath the covers, if you look, or if you spend any time with it, you'll feel like you're writing in JavaScript. It's often the sort of the common, lowest common denominator, it seems like, with a lot of modern languages, or specialty languages. Although you will find some that are, maybe they're like C# enhancements or extensions, or Java. Actually, you see a lot that are, maybe some sort of a Ruby or Python or something like that, because some languages are just built, they're just generally built better to be able to extend it and to add onto it. Sometimes, the code generators, typically, it's not uncommon for drag and drop to be a way to put together your application. Sometimes it's going to be XML. You go in, you configure it. Think back to the Hibernate example. And then, as I've mentioned, code generators are not necessarily, really aren't low code or no code tools. So if you go Google no code solutions, you're going to get a set of results. If you say low code, you're going to get, probably some overlap with no code, but you're going to get a little bit different. If you look at code generators, then that's another level below, essentially, and it opens it up to a lot more options that are out there. And with low and no code, really, those solutions are also low to no customization. And I mean like functional customization. You can change colors, you can change labels and stuff like that, but functionality, they're going to be pretty much static and set in their ways. Code generators, you're presented functionality, but there is, in this definition, there are going to be ways to customize that, to change it, to rewrite it. And depending on the code generator, maybe extremely or just minimally. So just some keys about code generators that I don't think some of this is really just sort of this stuff, maybe that's stuff that you've heard of before and you haven't really thought about it or forgotten about it. Code generators have been around for decades. I know back in the late 80s, early 90s, there were code generators out there, especially when object-oriented was really becoming big. IBM actually had a whole fleet of stuff that is now, I think, has devolved into NetBeans and whatever there's WebSphere or whatever it is that whatever their latest product name is for their application server. But they had Visual Age for a whole bunch of different languages. They had it for C++, they had it for Java, they had it for Smalltalk, and those were, essentially, they were IDEs, but they were really code generators. They haven't. The name is sort of faded from commonality. If you look at it, if you look for case tools, which is what they used to be called, more frequently at least, which is computer-aided software engineering, as you can see from the next little icon there. But if you go looking for case tools, you're going to find most of the references are probably turn of the century, this century. So, like 2001, 2002, or back into the 90s or the 80s. And it's an interesting thing if you want to geek out on computer science a little bit, is you can go take a look back at what the terms like there's uppercase and lowercase tools and things like that were discussed a lot, particularly in I guess as early to mid 90s, because that was sort of a heyday where people thought that we were going to quickly get to a point where nobody wrote code anymore, which we know now, a couple decades later, that didn't exactly come through completely. But also, this has sort of an ebb and flow, just like artificial intelligence or fat versus thin clients, is that it just seems like every so often, maybe 5, 10, 15 years, I'm not sure exactly what the cycle is, but you'll get some people, there may be some technology advances or new languages or something will spark going back to something that we've looked at before. Fat and thin clients, if you go back probably back in the 90s, I think was probably the first time that you had when you started having PCs and they were common, that you even had the idea of fat clients, because before that everything was a green screen off of a mainframe. So there was no such thing. It was just client. It was always a thin client. And we've gone back and forth. You can look at how client server stuff has moved around, especially now how browser stuff. There was a period where nothing was run on the browser. It was all HTML. Everything was server side. Now you see, particularly with JavaScript, you see a lot more stuff, a lot fatter, heavier client-side stuff. You also see that now as we've extended into mobile applications where you have a full functioning client almost. You have even a detached environment where you still have applications work, which would be definitely almost a definition of a fat client in that case. And you see this with case tools is people will code a bunch of stuff, and then some things will happen where there's maybe usually it's probably it's going to more likely related to like processing speed and memory for general PCs and desktops and laptops. You'll get a big jump in desktop power, and people say, hey, this thing that took a lot of time and a lot of work and a lot of processing to generate this code, well, now we can do it in a much more realistic, user-friendly fashion. So we'll do this for a while. Or you'll find maybe some really impressive framework or something like that just sets the stage very well for automation, for automating code generation. So you'll see those kinds of things will impact whether it's a hot thing or something that people say, nah, nobody wants to worry about that. So let's look at some strengths. We'll start on the positive side. And this first one, fast to market, that's really actually what prompted this whole presentation. And usually should prompt our consideration of whether or not we even want to use one. As you look at stuff, you say, okay, I've got something I've got functionality, I've got features, I know what they are, I've got the design basically done. And so now I need to get as fast as possible from my vision, from my functionality to users. I got to get this thing to market. Code generators can do that for us, because we don't have to sit there and type all that stuff. Computer can generate code way faster than anybody's going to be able to sit down, think through it, and type it. It's going to reduce the team size. If you need to get there quickly and cheaply, then that may be key, because if you've got a lot of code to generate, if you've got a lot of data to deal with as far as, for example, think you've got a lot of tables and a lot of columns and things like that, to write code that would work with all of those columns and all of those tables and all of those relationships, even just basic CRUD stuff, would be very time consuming. Even if you find the cheapest, $1 an hour programmers somewhere, that's going to be a big team. And there's just a lot of man hours that have to go into that. Or to be politically correct, person hours that have to go into that. So a code generator is going to speed that up. It limits human error. If you've got all these, humans, maybe think about the old idea of an infinite amount of monkeys on an infinite amount of keyboards will eventually get the works of Shakespeare. We're not that far from monkeys when you think about us banging away on the keyboards. All of us, I know, every day we have to backspace, we have typos, we have all this kinds of other stuff. And we don't catch it all. Sometimes we don't catch it until we see the application run, or until the compiler points it out, and things like that. If we've got a code generator, then that should, and other than like maybe name collisions and stuff like that, a lot of that code is going to be just set in stone. It works. It's been tested. It's been generated a bunch of times, so it's going to have a base quality that's probably higher than a bunch of people typing it in. Another nice thing I think people underestimate a positive of code generators, and actually this even would apply to low and no code solutions, is that you have less decisions to make. It has already, and it being, that generator, that tool, and really the people behind that have already sat down and designed pieces of functionality and how they work and what their core code and approach and inputs and outputs and all that kinds of stuff. Those are decisions you don't have to make. And so that's stuff that you don't have to think through. You don't have to worry about it. It's just like, boom, I'm off and running. And so that can save in itself a lot of time, a lot of frustration, and human error as well. So with all this, you're going to get higher quality from the start. Your baseline for quality is going to be higher because you've got this stuff that's been generated, that's automated, that's been tested before. And with that, that means you can probably have a more limited test cycle because you don't have to retest the stuff that other people have already have built and tested. And some of the generators even have, like, part of what you get is you get sort of like a regression test suite or scripts or something that you can run that is a validation process of the generation. So you don't have to worry about it. It's essentially almost like a black box. You just say, hey, crank that code out. We're going to trust it. And you get to move on to more interesting things. However, there are downsides as well. Usually with a code generator, you can find some, and you'll see some that in the examples that are open source, or you buy a license for the development environment or something, and then you're done. But the more powerful ones, more likely you're going to have ongoing costs. You're going to have like annual licensing or something like that you're going to have to worry about. So while there's a cost to write code yourself, there's usually going to be a cost also associated with generating code, and it's going to be, an ongoing cost. You also are going to have some level of vendor lock-in. There are very, very rare cases where the code generators just generate pure, plain code in whatever language it is. More often than not, they're going to have some of their own libraries and reliance. They're going to rely on certain things. Maybe they have certain frameworks or something that they build on. And so you have to, there's a vendor lock in there. You can't just take that code and completely run away and do something else with it. You still have to worry about those, some of those core libraries and that being available. And even just, there's a mental lock in because they've gone on and done those, they've made some of those decisions, and there's a design and an architecture that comes with a code generator that you're now sort of, you're essentially locked in because you're building on that stuff. So that means that design, that architecture is also going to be at the core of your solution.
Rob, one thing I was going to bring up, this is Franklin.
Yeah.
One other big negative is abandonment of the product by a vendor.
Yeah, and that's really, to me, that may be cost in that is a big deal, but I think vendors disappearing may be the number one risk of vendor lock-in. Sometimes they just price their product out of the market, but sometimes they essentially disappear. And that's, you could run into that with anything, but especially in a case like this, if you've got something where they have, some link back to their code or their source, especially if it is a black box, then if they fall off the face of the earth, if they go out of business, then you're stuck. You may not get security updates. You may not have stuff that supports newer versions of a language. Maybe you're in Java and it worked in Java 6, but now it doesn't work maybe for Java 8 or 9 or 10 or something like that. So there are a lot of risks with vendor lock-in that it always is something. I think to me, it's something you always want to avoid where you can. But yeah, excellent point. With code generation, less granular solutions are limited. And by that I mean there's sort of like a baseline. While we talked about a baseline of quality, there's also a baseline of complexity that the application is going to have. If you think back to, and this was actually one of the knocks against the visual age tools that I mentioned, and actually it was a knock against Smalltalk itself, the language, is that there is the underlying framework, the stuff that you need, the resources you need to just run a hello world in that generated code can sometimes be extensive. Like a hello world app that's 5 meg of space is huge when you consider that you could write one in less than a kilobyte in a lot of languages. And that's even, there's always going to be some of those costs, but when you get to code generators, because there's more that they provide you, that also means that bottom line is probably going to be higher, and maybe quite a bit higher. So there's always the risk essentially that you're going to run, that what that thing provides you, what the generator provides you, is actually far more than you need. Maybe you're starting with the Porsche when all you need is the Yugo. So that can be a weakness to them. You sometimes have to find the right code generator for your specific solution or situation. Because of that, I say harder. The note I have here is harder to customize and extend. Harder, saying that is sort of a loaded phrase, so that's why it's hard to figure out how to word that one. Generally, the issue with code generators is not necessarily the customizing and extend portion, is that you have to understand, usually to some level, what they've provided for you. I talked about that. There's an architecture, there's a design, there's an approach that they take that you pretty much need to follow that. You can't go off and have your own architecture and design. Even if you extend it, you're going to have to do it within their context. Hibernate, again, is a perfect example. There are things that Hibernate does very well and things it does very poorly. And if you want to try to address those weaknesses in its architecture and its approach, you're going to be really hard pressed to do so. Now, you could go into the source code and you could start rewriting everything, but then you start running into this, defeating the purpose problem. It's like, okay, if I have to work really hard to make a code generator get what I want out of it, then why don't I just start from scratch anyways? And related to these last couple of points really is what you end up with is typically, because code generators are focused on generalities and they're solving general problems, they're probably going to be slower, use more resources. Just general performance is not going to be as good as they would be if you specifically wrote code to solve your problem, because you're able to make assumptions and shortcuts that they're not able to, because there's certain things that you don't have to worry about, that they don't know that in the general case. I mean, think about like the most simple thing of a calendar or to-do list kind of thing. If you know that you will never have a recurring event, then you don't have to worry about all the code that relates to asking for a recurring event, and how does somebody tell you how often it occurs and how frequency and all that kind of stuff. All that stuff is ignored if you don't ever have to worry about that. However, if somebody's writing a solution, they're going to have all of that, all of that functionality, which means that code's got to be there, the interface has got to be there, all of that good stuff. So just sort of flipping back, think about the pros and the cons and just a general summary of those. Code generators in typical are awesome for standard type projects. Again, much like as we've mentioned with the low and the no code kind of solutions. So things like any CRUD, code generators often are really, really good at CRUD tasks, because they're just well suited to that. There's not, it's basically you insert a record. There's not a whole lot of bells and whistles that go around that. You delete a record. It just is what it is. It's just a function. It's an action. There's a limited amount of ways that you can approach it. So it's perfect for that. Even things like, customer relationship management and billing and invoicing and address books and stuff like that. Things that are just from instance to instance to instance. It's pretty much the same thing. Yeah, you may have a label here that's a little different. You may call it an employee instead of a customer, or street address versus address, or zip versus zip code. That's very just surface kinds of changes, but the underlying functionality is really, really close to the same. So those kinds of things are perfect for code generators. They give you a really good foundation, and often are pretty easy to extend. That's a pro. Con, again, look at it. Sometimes customization can be very difficult. You have to think about it the way that they do. You have to understand how they implemented stuff. They may have an API or technical documentation that you're going to have to pore over. And sometimes they may architect or design into a corner where you literally are not, it's impossible with their system to do a certain, to have a certain solution. I think that's very rare. I have worked in a lot of code generating tools over the years and environments, even some low and no code environments. And I am always amazed at how, if you've got some hooks in there for people to go in and write custom code, like pure custom code, they will find ways to take a CRM generator and use it to build a side-scrolling PC game or something. I mean, it's amazing what people will try to do with stuff and can find ways to do so. So it's difficult, expensive, maybe impossible, probably not literally impossible, but definitely not really feasible or unrealistic. Could often happen. You're definitely gonna look. There's a payoff. Your application is going to get to market faster, most likely. It's probably going to be baseline a little. It's going to be higher quality. There's some things like that you're going to get out of it, but you're going to pay for it in performance. Most likely, it's probably not going to be as fast, not going to be as tight, and there may be ongoing costs. So if you write a code, if you code a custom program, you write it, your code's done, ship the program, you can maintain it, but generally you're done. You don't have to pay for it anymore. You don't have to go back and pay for that code. With a code generator, if they've got annual licenses, then you're probably gonna have to go back and pay that cost every year. And the moral of the story with all of this is there is no silver bullet. There's always gonna be trade-offs. There's always gonna be things for us to consider. So I don't think we ever have to worry as software developers and engineers, IT professionals in general, that our jobs are here to stay in some extent. I mean, they will change, but there is nothing out there. I don't think we're going to be able to create something that essentially eliminates all of the work and the design and the thought that we have that goes into typical solutions. So now we've spent a lot of time on that. I do want to talk about frameworks and sort of the middle ground approach, because sometimes pure code is just too slow, and sometimes code generators is too much. It doesn't get us quite where we want to be. It's definitely worth considering things like frameworks and libraries. They're going to be slower to deploy than generators, even though they may have a code generation piece to them. Again, I keep flipping back to Hibernate. That would be the example. Is it will generate some stuff. But usually frameworks and libraries, I mean, they are built for people to extend them and customize them. And so that becomes very useful to us. It gives us a jump start. It gives us a baseline that we can work from. They can be incredibly powerful once you understand how to use them. When we talk about some of the examples, I'll throw a few stories out on those that are very similar, that definitely highlight that. They're going to lead to shorter deployment cycles. Again, we don't have to spend as much time designing. We don't have to spend as much time testing the framework code. We have a baseline of stuff that we can trust. And maybe you don't trust vendors, but for the most part, if you're spending money on a framework or time to implement a framework, then you probably trust them enough that you're going to think their stuff is, for lack of a better word, maybe in quotes, good. Usually because frameworks are used by multiple customers and multiple industries and maybe even multiple platforms, the quality is more likely to be good than if you've built it yourself, because just it's going to be a lot of people have used it and tested it. And so if there is a bug, somebody will have probably already found it, especially in the day of Google and the internet, and that you can probably search and see if what you've found is a new and unique bug or something that's part of that framework, which even helps you, because then you can figure out a lot of times whether this is most likely in the framework or is the problem code that you created, that you customized. As I mentioned, frameworks are going to be easier to customize and extend definitely than code generators, and sometimes even our own code, because they are built to be extended, customized, and built on top of. That's something that we probably, when we go in from scratch and write an application, we probably build stuff in a way that we have a core or a foundation we build on top of, but sometimes we don't. Sometimes we just sort of slap some code together. The next thing you know, we've put together an application. Resources as far as coding, extending, maintaining, people that can work with a framework or a library are going to be more prevalent than those that work with code generators. Code generators tend to be much more niche in how they are used in people that have exposure to them, simply because they do not have as many, where they may have lots of people that using applications built on those. They may not have as many people that have exposure to the generators themselves. Frameworks are going to be much more likely because there's more work available for them. So if you wanted to, if you were just getting started out and you were trying to figure out what was the best way for you to go in your career, obviously think about it. Learning a language, particularly one that you know is going to be around for a long time, is going to have the most general application. You're going to have the most people that are going to have potentially jobs in that technology. If you step up the frameworks, well, then it's just going to be people that have bought that framework or used that framework. If it's a popular one, then it may be a very good investment. Get up to code generators, there's not as many people that are going to, companies that are going to use it. And because they don't need resources as much, since you don't need big teams to maintain and configure code generation projects, then there's not as many jobs to be had out there. Also, frameworks tend to be lower cost. There's a lot of open source ones out there, but even if you purchase a framework of some sort and the tools around it, they're typically going to be lower cost than code generators because they leave more up to you.
Rob, I was also going to bring up that code generators oftentimes have a much higher cost to enter the market. So if you're going to be working with something such as a MuleSoft or something like that, you're going to have a much higher licensing cost to get into it. So just as a side note, whereas a lot of the frameworks are more public.
Oh yeah, as a student, if you're trying to learn it, then there's I didn't really look at it that way, but that's actually an excellent point that I've left off. If you think about it from a practitioner's point of view, you will find that source code, you can find stuff everywhere. You can go out and you can find YouTube channels full of ways to learn source code. You can still find, for the most part, with most frameworks, you're going to find ways to learn it. There's going to be online tutorials. At the very least, there's going to be vendor sites and things like that. As you get up to code generators, it's amazing how many of those you have to like go to a class, pay to go to a class, or pay for online learning. Some places you only get training with purchasing the product itself. So you would have to actually work at a company that purchases it, because it's usually not going to be stuff that you have as an individual developer have the money to spend to have a copy for yourself as a developer. So definitely, as you get into the generators and especially even up to low code and no code solutions, it gets the cost entry definitely goes up probably almost exponentially as you go to those higher levels of things already done for you.
All right, so I'm now wondering if I'm making a mistake with my code generator, because almost all the negatives you pointed out here, mine doesn't have. So, because my code generator or my test generator literally is just building the test framework with all open source frameworks, and pretty much it's Java. I mean, it's just poor Java with the testng on top of it. I mean, right now it'll build you the entire test framework, which typically takes a company about 6 months to develop.
Right, but that's the strength of that's part of what we've talked about. That is the strength of a really good code generator. The best ones out there use they write it as close as possible to how a developer would, so that you have as minimally as possible lock-in, that you don't have a vendor lock-in, because you have freely available source code and libraries and frameworks, templates, whatever it is that you're using, so that somebody can use it, they can generate it, and they can walk away and they can still use that. Now, you do still have, there are definitely still some of the pieces of the weaknesses that people would have to consider, because there is a since you have a test generator, there's an approach to testing that you use that is part of that that generator. Now, whether, sometimes, which I haven't gone deep into some of those areas, sometimes they are those assumptions or whatever, those approaches are best practices, so that, it can in some way be a way that you learn, essentially learn by doing best practices for a specific approach. But it is, from a business point of view, putting a different hat on, if you think about it, is that from a business point of view, what you're providing is something that somebody could come in, generate their stuff, walk away, and technically never have to deal with it again. I mean, they could just extend it. Now, if they wanted updates or regenerating and stuff like that, they would, there would be an issue there. They would have to, instead of regenerate, they wouldn't get that benefit. They'd have to recode it. If you were more, I don't know if you want to say savvy or whatever, from a business point of view, what you would do is you would build in, potentially you could go build in pieces that would require people to come back and pay regular licensing fees and stuff like that. So it becomes it depends on how you want to approach stuff. And I've been on both sides of that, or looked at it from, been in products that have come at it from different sides. Some places people want to, if you're putting the time in to create a code generator, you want to have some level of lock-in as a vendor, so that people will keep coming back to you. In some cases, don't. Some cases people are going to say, hey, I'm doing this as it's not entirely altruistic, but as a benefit to the community. And so I'm going to do what I can to avoid lock-in. And some of these they're built because the money that they're going to get out of it has nothing to do with the code generator itself. It's really to help people, their user community, which is some of these examples we're about to talk about. It helps their user community, and there are other ways for them to either make money, or they're an open source project where really it's everybody is trying to contribute to the community, and you have something that then by its nature is not going to have that same level of lock-in, because people, they don't want to be locked in themselves. And that's
right. And that's one approach I've been thinking about taking. So the base code generator, which just generates the raw code, I've actually thought about just selling that at a flat rate of $79 for a yearly license, or for that version. You basically own that. You can run it as many times as you want. You get 1 year of updates, and then at the end of that, you would have to pay essentially like what's the one we use for the database tools all the time? What's it? Virtual.
Oh, DB Visualizer.
Yeah, DB Visualizer, where every new version, like full version, you essentially have to pay a small upgrade fee to get the new version, and then the licensing or the lock-in essentially would be the GUI piece that I would put on top of that, which would either be a web-based interface or a GUI component that you would have to essentially pay for, that would auto-generate, and you could then build and control all your tests through a nice GUI with no code at all.
Yeah, and there's stuff there are many ways to approach that. And you can even look like PHP Runner is a good example of something that's same thing as you do it. Actually, a lot of the IDE tools, if you look at all the Storm, I forget the Java one. It's not Storm, but there's like PHP Storm and Web Storm and all that, which is those guys. It's and PHP Runner does the same thing. As you pay a certain fee for the first one, and then after that, you're a previous user or something, and so you can get it at a lower cost. Adobe used that for years before they switched to the subscription model, and I think they probably still do. So if you buy Photoshop the first time, it's $1,000. If you buy it again, and I think theirs was usually pretty neat, because I think Adobe had, you could buy one, and then if you bought another one within like the next 3 or 4 versions, then you would get it at a much, much lower price, like 80% off or something like that. So it all comes, that really gets into the, what's the business model you even want to approach with if you're, if you're building a code generator or a framework. And even in your case, some of it, since you have a combination, is some of it's how do you want to position it? Do you want to position it more as a framework? Do you want to position it more as a code generator? And there's a lot of decisions related to that on how you would want to market it and who you would want to go after. It changes your target market based on what those decisions as well. So some
Right.
some common options out there and this gets into what, like I said, sort of swinging back around to some of the ideas that are out there. If you want to do a quick solution to a problem, there's stuff out there in just about every language. Django is the material version of it is a fully featured responsive CSS UII kind of thing based on Django's built on Python. It is very quick to bring up an application if you want to do particularly like CRUD kind of stuff with an admin tool, user security is built in, stuff like that. As far as a typical web-based application, you can spin something up very fast with Django and be able to do CRUD type work, and then even customize it pretty quickly. So you can have an application that under the covers is essentially a CRUD type application, like a customer relationship management. At its heart, it's really just a prettied up CRUD application. You're adding records, you're editing records, you're doing some views of it. Django is really good with that if you're in a Python world. If you're in the PHP world, there's several frameworks. Laravel is probably the most, in my experience, one of the most database to front end generators that's out there. It's much like Django is to Python, Laravel is to PHP, I think, which actually the next one down there, Ruby on Rails, is to Ruby. Java Spring, actually, it's got some pieces like that. So these first four that we see on this list, they're well designed to, once you have your database, or as part of creating and designing your database, is that these things use those files, that XML, that configuration, and are built to help you generate the database and generate essentially a front end for that database. And that allows you to very quickly have a core application that you can start running with and build, because all of these are in there. They have a core general language underneath the covers. Then you have that basic interface database, your model view controller type of approach, typically. Definitely a client server type application that's just like, boom, you're off and running. And then you can start customizing and adding features and really get running with it. So they are frameworks as well as code generators, but definitely get you there very quickly, depending on what your favorite language is. A PHP runner is much more of a full code generator, almost really pretty close to an app generator, even though it does give you full source. The source code itself is complex, or at least I haven't messed with the last couple of versions, but in older versions, it was very complex to go in and start customizing and building out your own stuff. You pretty much had to live with the code they did and then build on top of it, which was not always, sometimes a sort of a clunky interface, but it was also very powerful. You could have a really nice looking application quickly. And they did provide, instead of having to deal with XML or configuration files, they had a nice GUI to allow you to design your database, design your screens, all kinds of themes and stuff like that. So you could put together a pretty slick application really fast. And I've had customers that that was the project. As I went in, built them a PHP runner application, and they had something that was incredibly impressive to them in a very short period of time for me. Some more that are out there that are a little less, maybe a little less heard from, is vFront. Like I said, this will be good for probably take a look at these slides. There's vFront, JHipster, which interesting enough, even though it's got the J and J hipster, there's several languages. It's not like just a Java solution. Spring's Roo has come along over the years. It is very much takes advantage of the Spring framework. And annotations and things like that. But it is actually it's one of the things it does besides being a really good way to quickly get a CRUD application built. It generates code that you can take a look at and get a really good idea of how powerful annotations can be in Java, and particularly in the Spring environment. And I'm not going to try to pronounce it, but it's basically, well, actually I am, I guess, but basically Open Zava or whatever it is, Xava is another. It's much more with the open. It's an open source attempt to build a code generator, low code kind of solution. The Cuba platform like that as well. And I list these really because it gives you a starting point. If you're sitting there saying, I've got an idea in my head, I've got data I need to get in front of users in a pretty way or with a good user experience, then I think it's useful to know that there are lots of these tools out there. I mean, this was in a very short period of time, and off the top of my head, throwing some stuff together. If you really want to spend a little time researching, if you're in a company, maybe a startup or something like that, that this is potentially a path you want to take, then you could easily find a lot of solutions out there. They probably would be a little bit time consuming to review them and evaluate them, because you're going to want to look at generated code. You're going to look at, actually dig into the code and see if those architectural and design decisions made are suitable for what you want to do, and if the extendability of it is something that works for what you need. So swinging it back around, so sort of just a general summary of what have we learned. Hopefully that we've learned through all this, there are a lot of ways to generate an application. We do not have to write raw code. I haven't even dug into the wide ranging. There's definitely a spectrum of options available out there, to very simple, very minimal amount of code generation, up to very complex, essentially full-blown application generation, and just about every point in between. Even as Michael brought up, there are a lot of things out there that are combinations that are they're frameworks, but then they've got some tools on top of them or alongside them to help generate code within that framework. So there's just a lot of options out there. If you want to be lazy and avoid writing code of some sort, there is probably a tool for you. Typically, there's going to be a cost related to that. Either pay now, where you have to buy it, you have to license it or something like that, or there may be a pay later kind of cost to it, that you have some level of lock in to their design, their architecture, their approach. Sometimes, a lot of times the frameworks can give you a middle ground. They're going to give you enough core functionality that you really don't care to deal with, and then allow you to move forward with that. A perfect example would be, think of like the OAuth stuff that's out there. Just about every application we deal with needs to have security, some sort of authentication mechanism, some way to log in and have a user and a password and pass around a token or something to say they're authenticated. It's been done a billion times. There's nothing, probably, unless we're building a security app of some sort, there's nothing we're going to bring to the equation that somebody else probably hasn't already thought of. So if we can find a framework or something that provides us that functionality already, it saves us headaches, it saves us time. It's probably worth money to purchase that framework, even if we have to. And there's always on this spectrum, the more you automate, most likely the less there's going to be opportunity to customize, and definitely opportunity to do performance tuning and things of that nature. So it's, if somebody does more work for you, then you have to rely on them more. If you do more of the work, then you have more freedom to do it the way you want to do it. All right, questions, comments?
Yeah, it's so funny.
Hey,
I'm sorry, go ahead, Michael.
No, go ahead. You start.
Yes, sir. I was working on a new project in which it just need to set up a ORM, and Hibernate was the way to go. And just, the whole CRUD back end is generated. So you don't think about it as you move along, but it's integral in every part of, in practically every application you do. And then another comment I was going to make was, as you move along in your career, you start using your own code generators to do things that you find yourself doing often. And so I just want to say that it's so integral to what we do as developers and engineers.
Yeah, and it's becoming more something we have to be more, I think, intentional and cognizant about. Is if you look at the way languages are progressing, if you think of whether it's Maven or some of the other library containers like that, or Composer, or PHP's approach, pip, or Ruby uses gems. You look at all these languages, and now it's so easy, although they do library management and stuff like that, it's so easy to just throw libraries in, and that alone is can bloat stuff and can put you in a situation where you can have something that becomes you have just more stuff than you need. And so it's easy to forget, but it's often good to look back and realize how much has been provided for us, and also that's not only provided for us, but that's essentially baggage that we're carrying along with us. So we want to make sure that we do that in as smart and intentional an approach as possible.
Yeah, and you mentioned it, the bloatware that comes along with code generation. There's a question there, but it's not coming to me, so I'm gonna call it dad brain. So, but you're right. All of that is so important to make sure we reevaluate. Thank you for this.
Hopefully you can remember yours while Michael says what he was going to say.
Yeah.
I was going to ask if you could post those links out on Slack, so I don't have to go through the video and try to type them all in correctly.
Man, see, programmers are lazy. Just yeah, I'll do that. Actually, remind me if I don't, but I'll do that right after I wrap this one up. I'll go throw those out there in Slack. I'll throw them out in the tools. So there'll be a whole flurry of links that go out there.
Thanks.
Other questions, comments, or Tim, if you remembered what you were going to ask?
I do remember.
Excellent.
So when it comes to code generation, there's obviously a line, and that line is probably different for everyone. But what would you say is the best way of evaluating the balance between the bloatware that's generated versus the benefits, that's it, that the code generation is going to provide? What do you have to say on that?
It's the same thing that we run into all the time, is that it really comes down to the core of whether it's the why you're building that, or also put, a lot of times we talk about the actual problem you're solving. Is that sometimes a lot of times it's going to come down to, if you look at the problem you're solving, sometimes a code generator is going to get you there very quickly and solve that problem. Sometimes it's going to get you close, and you have to figure out, how can I go from close to exactly solving my problem? Or in some cases, it'll get you solving a different problem that's close but not enough. And then you have to decide, is that close enough that I'm going to be comfortable with it, with whatever additional stuff I need to do to take it the final yard, essentially, to solve my problem, or is it not worth it? And then you have to balance that with long-term use. Like a one-off, if I'm just building something that I'm going to solve this problem and run it one time, then a code generator may be exactly what I need, because I don't want to spend any more time thinking about it than I have to. I just want that job done and move on. Right. If it's something I'm going to do every day and use a bunch all the time, then I'm going to have to take that into account, because maybe then I want something that I can, more finely tune it to exactly the kind of the solution that I want. So it's very much problem specific, and the way we look at this is in any situation, you would have to look at the pros and the cons of the given code generation solution versus what are your other options, and then compare them out that way. But as everything does, I think in software, it always comes back down to what is the problem we're solving? What's the solution that we're trying to provide?
Rob, one thing I would bring up also is a lot of people are shifting things more to the cloud. You are adding baseline costs, variable costs every time. So the more overhead that it has, the more CPU cycles, the more storage it takes. That can come into cost benefit analysis. So it's one thing when you're tucking things that are basically all on premise, but as we go more into the cloud domain, that shifts the costs of running it every day. So just
not only that, that impacts the feasibility of it. I've got a lot of customers I talk to right now that are, there's a bunch of people I've talked to in the last few months that they're all, a lot of them are doing like SharePoint projects and stuff like that. They're Microsoft shops, and Microsoft has shifted. They have cloud versions of like all their stuff, even up to CRM and Navision and all of their tools. You can get on-prem and you can get on cloud. And of course, on each of these tools, there's other tools that other vendors have come in and built stuff on top of it. And there is that's a lot of discussions are around, does it even work? Will this work for us if we go from our classic on-premise to the cloud? And then if we move to the cloud, what are there some trade-offs? So there's some things that we're not going to be able to do. And it does change stuff quite a bit. And so the architecture and the design sometimes it becomes not only, which is very key, that's a very good point, is the idea that now something that's slow and expensive to run locally may be way too slow and expensive to run in the cloud. But also you may not even be able to have, because of security and maybe VPNs and all these other requirements and things like that, it may not even be feasible for you to run it if it's in the cloud versus a on-prem solution. And so that does go back to one of the things, really back to Timothy's question a little bit there, is sometimes everything may work out, and where you run it may be the thing that makes it a yes or a go or no go kind of decision. So yeah, very good point.
Excellent.
Any other questions or comments? I talked over you there, Timothy. I'm sorry.
No, I was just saying thank you both. That's a good point.
Okay. All right, then. Well, thanks everybody for the listening through the presentation. Some great questions and comments and things like that. As always, appreciate your time hanging out with us. Listen to this, whether you're listening to it live or sometime later. As always, if you have any questions, you think about anything afterwards. If you also are lazy and want me to send you a list of the of all of the options that we threw out there, you shoot us an email at info@developerpreneur.com. We do still have a Facebook page, Developerpreneur. Shoot something out on Twitter at Developerpreneur, or you have a contact us form out there at developerpreneur.com. And as always, we're just going to keep doing this together and try to make every developer better every little chance we get. So thanks.